Hello everyone, my name is Doug Zurich. I'm the product evangelist here at Peer Group. Peer Group is the leading supplier of factory automation software for both factories and OEMs. We're best known for our semi-standards compliance solutions that implement SecGem, EDA, and similar, but we have a full suite of products available to help both factories and OEMs achieve their factory automation needs. As we've been speaking to our customers in both these worlds, the factory and the OEM side, it has been very clear that people are becoming more and more concerned about cybersecurity and how to make our semiconductor manufacturing facilities safe. So today I'd like to talk to you about how we're going to get to safe. What are the challenges that are out there? What are the opportunities we have to improve? And how there really is a solution to this problem. And rather than maybe just ignoring the problem or worrying about the problem, it's time for the industry as a whole to get together and start to solve it, which is something that's already happening. Certainly something you never want to see when you come into the office is to find out that your company has been the victim of a cyber attack. This could be a virus getting in, a ransomware attack, hackers coming in trying to steal some of your intellectual property. This is happening out in the real world today. We've seen it inside our industry on multiple occasions. This type of incursion into our semiconductor manufacturing process can be incredibly costly. We see estimates up and above $250 million per incident, and it has a kind of ripple effect throughout the industry. Because, as much as semiconductors is a gigantic, soon-to-be trillion-dollar market, in a lot of ways it's a small industry. There's not that many players here. A lot of the supply chains are, coexist, and we're buying from the same people and selling from the same people. So if one part of the supply chain is disrupted by a cyber attack, even if it's not your facility, even if it's a supplier or the supplier of a supplier, that can have a direct impact on your ability to produce microchips, your ability to actually serve your customers. So we're very much in this together. It's not a case of just being able to protect ourselves. We need to protect everyone, and we need to protect everyone all at once. This is a problem that's going to be dealt with as an industry as a whole. This cannot be just one OEM or one factory taking it seriously. We all need to take it very seriously. The economic impacts are simply too high to do anything else. So I'd like to be able to talk to the experts in the field, and certainly one of the biggest experts is a man by the name of Bruce Schneier. Bruce Schneier gives wonderful talks on security. I encourage you to look him up, and he has this one quote that I think is very relevant as all of us approach this problem. It's not enough for the average person or company to be afraid of cyber attacks. They have to believe that there are fixes to the solution. There's two parts to this. We need to understand that cybersecurity is a real need for the industry, that the challenges do exist and that they can cost us money, but we need to believe there's solutions. It's not good enough just to panic and say, oh, we can't solve this problem, it's too big, it's too scary. We need to understand that there are ways to fix this problem. Bruce likes to give the example talking about cost benefits when it comes to any of these cybersecurity type initiatives. Certainly you could be very secure by spending an infinite amount of money. Not perfectly secure, but you can spend an awful lot of money. But putting the right level of resources, right level of costs against the right level of benefits, the right level of problems, the right level of challenges, the desirability or the vulnerability of a target is very important. So we need to be able to balance all of these different things. The example he gives is talking about a home security alarm. Some people have a home security alarm, some people don't. Certainly having an alarm is a way to help reduce the chances for theft in your home, but depending on what you have in your house, your personal feelings for safety, the neighborhood you live in, all these different aspects will change whether or not you need to install a home security alarm. And you can drag the analogy forward into the cybersecurity realm for our factories. There's a lot of different solutions out there. Some of them are procedural, some of them are engineering, some of them are going to cost money. We need to decide on the right type of solution for us. Now, the challenge, of course, is that we are in a lot of ways as a semiconductor industry in the worst possible situation when it comes to cybersecurity. Extremely valuable target, both in terms of just the money and the volume of sales that go through our industry. Extremely vulnerable in terms of we have very sophisticated systems. They've got a large surface area for attack. There's a lot of complexity of what's going on inside our factories. Any one of these different components, be it hardware or software, is a potential way for the bad guys to get in. And also there's extremely valuable intellectual property inside our factories. Someone stealing even a fairly small amount of intellectual property could capture a lot of economic gain. So we're a large target, we're an at-risk target, and we're a very valuable target. So all of this combined means that our home security alarms need to be quite good. So it is possible. I don't want to panic. There are ways, and other people have dealt with gigantic, scary safety concerns. And the one I like to talk about, the example I like to give, is talking about airline safety. The commercial airline industry has been up and running since 1950 or so. And if you just look at this chart here, you'll see the number of accidents is on the vertical axis, and then the size, the number of people who are killed, is the size of the bubble. And year over year, despite a lot of different changes, the total number of accidents and the size of those accidents, the number of people killed, has been steadily decreasing. Even though airlines are incredibly complicated. In some ways, like you could draw the analogy to semiconductors, very complicated, very visible, very present, lots of different vectors for problems to occur, and a very desirable target, either from accident or malice, and yet this has been decreasing over time. It's even more remarkable when you realize that those are absolute numbers. This is the total number of planes that are having some kind of an accident or a problem, and yet the volume of air traffic has gone up exponentially over the last 70 years or so of air travel. If we look at the number of fatalities per million miles traveled, that has fallen dramatically down over the decades. The airline industry has found a way to resolve their safety challenges. And what they did, it comes down to hard work, frankly. So engineering excellence is certainly a part of it. The ability of the airlines to achieve safer designs has come down to sweat and good old-fashioned hard work and brains and analyzing problems on the engineering side, making pieces more reliable, creating redundancy, making sure that a problem in one area does not cascade into a larger problem. Human factors are being dealt with, and this is very important. In the airline industry, there is a culture of, if there is a human error that causes a crash, if a pilot does something that causes a crash, you don't blame the pilot. It would be very easy to say, this plane crashed because this pilot did X, Y, Z. And certainly that probably happened. But you need to take it up a level and ask the question, how was it possible for the pilot to make that error? What circumstances created a situation where the pilot was likely to make that error? Why wasn't there a system in place to make it impossible for a pilot to make that type of error? So humans are going to be involved in the system, both for airlines and for our manufacturing, but it's not good enough to just blame them. You cannot say that, oh, our factory got hacked because somebody clicked on an email attachment, or somebody brought in a USB drive and they weren't supposed to, and that was infected and problems happened. Yes, that occurred. Yes, that human being made a mistake, but we cannot rely on that and say, oh, nothing we could have done. Humans are going to make mistakes. We need to build systems that allow for the fact that there are going to be human factors, and we need to make sure that those humans, it's impossible for them to make those kind of mistakes, or at least it's impossible for us to be impacted at a large level by those mistakes. And this goes into a continuous learning process. The airline industry is excellent at sharing information across all the participants to say when an accident occurs, when new learnings are happened, that information is shared, it's discussed, it's analyzed, and then it's reworked into the system so it doesn't happen again. That kind of process is vital because you cannot fix a problem once and be done forever. You need to be continuously improving, continuously seeking to get better. And the airline industry is excellent at that. We can learn from this. It is directly applicable to the cybersecurity of our systems. A couple more quotes from people. I mean, again, one of the nice things about cybersecurity, as much as it's a large challenge, it is not a challenge that is exclusive to semiconductor. A lot of the problems that we do face in the industry are very unique to us, dealing with these nanometer scale problems and precision and trying to create these devices at the billions. That's very much a semiconductor problem. Cybersecurity is not. We need to learn from the experts. We need to take best practices from anywhere we can find it. There's a lot of very smart people thinking on this problem, a lot of great organizations working on this problem, and we're going to do it with them. We don't need to necessarily build it ourselves. So Tony Sager, a chief evangelist of internet security, he likes to say that cybersecurity is more like Groundhog Day than Independence Day. So if you remember the movies, Groundhog Day was this movie where the same thing kept happening over and over again. So Bill Murray was living the same day over and over again. And that's very much what cybersecurity is like, as opposed to Independence Day, where the alien invader comes up and some heroic effort happens and you attack it and you destroy it and you're done, you've won forever. Cybersecurity is about doing the right thing over and over and over again. The challenges are never going to go away. You will never have that one silver bullet solution where you're going to solve it, say that you're secure, and nothing needs to change again. You need to keep on doing the right things over and over again. And the bad guys aren't magic. The bad guys are going to use the same techniques over and over again because they work. So you need to stop them, and they're always going to be going back and trying the old techniques over again. So you can't forget the solutions of the past. Going back to our cost-benefit analysis, in a lot of ways the 80-20 rule, the Pareto rule, whatever you want to call it, does apply, where some basic solutions, I'm going to say that, and you'll see some of them here, go a long way towards making us secure. Doing some of the, I'll use the words common sense, that's not completely fair, approaches will get you a long way towards being security. And we need to do a better job of that. One of the other organizations out there that can be able to help us is NIST. NIST is spending a lot of time looking at cybersecurity. They've come up with the cybersecurity framework that's designed for all industries, not just manufacturing. But it definitely gets you thinking in the right way about this needs to be a process. Yes, there's going to be the engineering solutions, you know, your virus checking, what have you, but security is very much about a process. So the process they've identified has got 5 high-level items. I don't have time to go into all the details here, but identify, which is very much about identifying where you might be attacked, what kind of vulnerabilities you're exposed to, what kind of attackers you might be exposed to, protecting everything that you've identified, detecting, making sure that you're able to recognize when something bad has happened as early as possible so you can mitigate what's going on. Once you've detected it, how you will be responding to any kind of attack or incursion or failure, and then how you recover from that. Talking to people in the industry, they really want to see the word avoid get put in the front of all these things. I fully agree with that. The Cybersecurity Framework 2.0 is being worked on right now, and I think there's a few people who want to maybe put a 6th step in there that says we need to avoid. So SEMI has recognized this problem, and they're doing a lot of great work right now to start really getting the industry to think maturely about cybersecurity. In particular, 2 major task forces have been formed. One of them, very similar names unfortunately, but that really doesn't matter in the names. One of them in Taiwan, the Fab and Equipment Information Security Task Force. TSMC put a lot of effort into this one. They really spearheaded it, got this going. E187 is the first output from that committee, and it's really about making sure that the design of your factory tools is to make them as robust as possible so that when they out of the box, they're as secure as possible. And then making sure that continues while they're in regular operation. The Fab and Equipment Computer and Device Security Task Force, big words, they go by CDS, Computer Device Security. That's a North American initiative, a lot of great work being done there as well. And they're very much focused on one of the areas that was identified as being the highest risk area, and that's when changes are being made to the tool. So a tool at rest, in operation, where you're not making changes, is safer. It's not safe, things can change. E187 helps with that, but certainly you're at your most vulnerable when you're making changes. So either when you're bringing the tool in for the first time to the factory, or as you're maintaining it, you're applying software patches, you're doing updates, you're making any kind of configuration change. That's the point in time where problems can occur. So a lot of overlap between the 2 standards, as there should be. They're protecting from slightly different scenarios, but they're both very, very important, and they do work together quite nicely. E187, so this is the Taiwan that's trying to based one, although it's certainly global, it's been adopted as an official semi-standard. It's trying to make sure that the equipment is safe as possible by design, not just when you're interacting with it, but by design. So it's really looking at 4 major areas. It's looking at the operating systems that are being on there, a major requirement that your operating systems must be supported. This gets into those common sense things where, sure, your operating system should be a currently supported one that's getting regularly scheduled patches and security updates. As I think most of you know, that is not currently the case inside our industry. The trend is very much being, I will build a tool, I'll deliver a tool, it'll run on Windows XP, we still see those out in the industry, and I'm going to ship it to the factory and I'm never going to touch it again. It's running production, the yield is good, I don't want to make any kind of mistakes, so rather than updating the operating system or patching it, I'm just going to leave it alone. Because certainly in the past, yield was more important than an operating system patch. The world we're getting into now, those two are absolutely interlinked, and the risk of a catastrophic failure because you did not apply a security patch or there's no more security patches available is exceeding the potential risk you're taking against your yield or the kind of downtime you might need to take to do these adjustments. So operating systems are very much at the forefront of people's concerns. Network security is important. It looks at that, makes sure that, again, this is one of the areas where you're at risk. We've identified, using that NIST terminology, that that's one of the areas where malware can get in, hackers can get in. So we want to make sure that we've got the appropriate levels of network security there. Endpoint protection, that's discussing malware scanning, checking your virus scanners, that type of thing. And security monitoring, again, in that NIST type of framework, making sure we're detecting it, making sure that we're watching for potential problems. Right now, some of our factories, they could detect a catastrophic problem, but they might not necessarily be able to detect a problem as it's initially occurring. Notable, this particular standard as it stands right now, and again, this is early days, is only applying really to PCs, to computers running either Linux or Windows. It's not applying to our PLCs, our SCADA systems, factory level systems, the MES systems. E187 is targeted at the control systems at the tool level. Not that these other things aren't important, they're just not covered by this particular standard. Going back to the operating system problem, you can certainly see that a lot of operating systems are falling out of support and have been out of support for a very long time. So Windows XP has been out of support for coming up on 10 years now, 9 years anyway. We do see Windows NT, we see DOS, we see all sorts of old things inside the factory. That's no longer acceptable. So we need to be able to find a way. Certainly no new tools should be delivered with these operating systems, even though they are. We are going to have to find a way on these older tools to do those updates. That's going to be challenging. A lot of these things haven't been touched for a very long time, but if we want to be safe, we need to find a strategy for that. But even, you start thinking about things like Windows 10, Windows 11 is out now. Microsoft has changed their strategy for how they're going to support operating systems over the long term. Again, not going to get into the details here, but they very much are expecting people to update on a more regular and more continuous basis. The times when they would deliver an operating system and agree to support it for 15 years are probably gone. Windows 10 was supported for a relatively long period of time. They targeted 10 years. Windows 11, it appears that they're going to shrink that. Some of the communication out of Microsoft hasn't been crystal clear, but it looks like that time window is going to shrink considerably, and they are pushing everyone towards continuous updates. And honestly, you should be continuously updating anyway. So while this will be challenging, it's not a bad idea. E187, again, it's got a lot of common sense. I'd like to call them type requirements, but now they're being made into a standard. They're being proceduralized. Any of your network communication should be secured. It should be encrypted. For this standard, it's particularly talking about if you've got some kind of web traffic or telnet or any kind of remote connectivity into the tool, that should be encrypted. And very often it isn't inside the factory. A lot of us have assumed that inside our factory, inside those four walls, we're secure, we're inside our castle. We don't need to worry about the traffic going through there. We don't need to worry about encrypting that. E187 changes that assumption and says, no, it must be encrypted. So if our tool has got a web-based dashboard or a web-based configuration tool, the communication to that must be over HTTPS using that bank level security. Any network connectivity on the tool, any open ports should be documented. Again, if you think about it, well, we probably should have had that documented from day one. All sorts of reasons why we didn't. Now with E187, that's being a requirement. The tool must document all of the network connectivity that's available, as well as what the change protocols are, so you'll be able to make change to that, change what ports are available, all that kind of thing. Tools should show up with any extraneous services turned off. Windows, naturally, was not built to be a tool controller necessarily out of the box. It's built for many different functions. It'll run on my laptop. It'll run my kids' video games. It'll run, who knows what. Any services that are not required should be turned off. By default, a lot of these things are on. It is now incumbent upon anyone who is E187 compliant to turn off services you're not using. Any service that exists there is a potential risk factor. That's our identification step. We're going to turn it off and take it off the list entirely. Hardware, very similar. For a long time now, our factories have found ways to disable USB ports, to remove them, either physically or electronically, cover them up with a piece of tape or glue or what have you. That's now a requirement to make sure that if you don't need the USB ports, shut them down so they can't be used. Again, we're protecting against the humans making a mistake. Also need to make sure that a lot of our tools offer logging for operations, for procedures, for the process they've done. Security logging, a minimal level at least to start, is going to be required. Any tool has to provide and identify where it's logging certain security events. I'm going to make sure that all of our tools are running malware scanners and vulnerability scanners. In the past, again, because we thought we were safe inside our four walls, very often we would not run a virus scanner on our tool. We'd not do virus checking there. The fear was that it could interfere with performance because virus scanners will potentially slow down a computer at time and unknown times. And also it was hard to get a new virus list or new package or updates to the virus scanner on a tool. Again, no longer acceptable. We need to find a way to be doing that virus scanning at the tool level, internally or externally, but that virus checking needs to happen. That's E187. E188 is talking about the actual integration process. So what are we going to do at those moments in time where we're either bringing a tool into the factory for the first time or making some changes? E188 focuses on trying to mitigate any problems that are going to happen there. And it's a very mature standard in some ways, that it's not avoid entirely, make it so that they can't possibly exist. Certainly that's desirable, but we also want to make sure that if something happens, we're able to make sure it doesn't spread outside and cause problems elsewhere. So there's very well-defined reporting requirements inside this particular standard, making sure that when you're making a change, when the tool is coming in, there's an exact list of everything that's going on the tool, what virus scans were run, when they were run, what virus definition file was used, what the results were. Very similar for any kind of vulnerability scanning. So when it comes to malware versus vulnerability, so malware is talking about viruses. So this is malicious code. This is the bad guy has written some code to send it into your tool and do something disruptive to it, whether they were specifically targeting or whether it's just a broad virus that was let out into the world. Vulnerabilities talks about scanning your software to see if there are potential known problems. So we certainly have heard out there in the world about, such and such a software has got a vulnerability. It can be hacked. It might be hacked. That would be a vulnerability. A virus or similar that's taking advantage of that, that's malware. So vulnerabilities are the possibility of a problem. Malware is the kind of the realization of taking advantage of that problem. So keeping track of all the vulnerabilities in the world sounds like a large problem. Trying to identify a list of every piece of software in the world that could have a problem is an overwhelming challenge, but the good news is, again, we don't stand alone. This is a challenge that's currently being addressed and being addressed very effectively. So NIST, again, the National Institute of Standards and Technology, has been working on this problem for a very long time. They've been working with the community, and they've got a number of different solutions. I'm not going to go into all the nitty-gritty details here, but there's a couple of high-level acronyms that I think would be useful to know. So SCAP, S-C-A-P, the Secure Content Automation Protocol, is NIST designed for an automated way to communicate and exchange all of this information about the vulnerabilities that are out there, about software versions, all this kind of thing. And what you can do is using these protocols, you can develop a scanner, and the scanner will, using the protocols, get a list of all the potential vulnerabilities and then scan for those vulnerabilities. A lot of words there. What it breaks down to is with a SCAP-enabled scanner, you are able to look at a given PC, a given piece of software, and scan it on a regular basis. You can't do this just once, and look for, are there any kind of known potential vulnerabilities going on with this? And this is fed by gigantic databases listing all of the different problems that are currently known to the industry. So the CVE, the Common Vulnerabilities and Exposures, is a list of all of these known problems. This particular software library, version 1.2.5.6, has a potential problem where hackers could get in. This particular one has got a problem where hackers could cause your CPUs to spike up to 100%, what have you. So the CVE is a complete list of all these potential vulnerabilities. Now, some vulnerabilities are more important than other ones. Some of them are very easy for an attacker to exploit. So if it's easy to exploit and it's on a piece of software that exists everywhere, that would be a very important vulnerability. If it's a vulnerability that's incredibly subtle and hard to exploit, and in order to actually take advantage of that problem, 17 different things have to happen, and it's on a piece of software that's only used once or twice, that would be less important. Maybe very important to you, depending on who you are, but overall less important. The CVE does not make any distinction between those. Where that comes in is the NVD, the National Vulnerability Database. So the CVE is a raw list that feeds into the NVD. Apologies for the acronyms. The NVD is what ranks all of these vulnerabilities and says, okay, how scared should you be? How immediate of an action do you need to take? In a lot of cases, you should always act on the CVE, but there's a difference between you need to act on this today or you need to act on this in your next scheduled update cycle. It would help to give an example. One of the scarier ones that came out recently, and it doesn't sound scary, Apache Log4j. So this is a logging library. It's free, open source. Turns out it's used all over the place. It's very close to being the default logging package for most Java applications. Java runs in a lot of places. Sometimes Java is hidden under the covers of our various software packages. Turns out there was a vulnerability in Log4j, and someone from the outside, I could type a message, it goes into your software logs it to disk using Log4j. Well, me from the outside, I was able to run whatever program I wanted on your computer just by getting something I typed to show up in that log file. So you can imagine if I type Doug Zurich into an application, a web page, what have you, very often Doug Zurich will get logged onto disk somewhere. Very common thing to do. But instead of typing Doug Zurich, if I type malicious code, if I type a malicious command, because someone's exploiting a vulnerability, a bug in the Log4j library, that code wouldn't just be written to disk, it could run an executable on the machine on the far side doing whatever I chose to do. Gave me from the outside effectively a lot of power and a lot of control over the computer on the far end. A very scary vulnerability. It affected all sorts of applications all over the world, well outside the manufacturing realm. So this actually so the CVE entry, Log4j has a bug where someone can execute code remotely. The NVD entry, and this is why it made the news, level 10, critical, this needs to be patched right away. Huge problem, people know about it, the virus writers know about it. So this triggered a very high level NVD notification. Anyone who was using an SCPAP scanner, that went through the system. They would be able to find out whether or not their software had the Log4j library, an older version that had the vulnerability, and then they could go ahead and fix it. So, simplifying a little bit, smart people in the world out there found this problem, they logged it to the CVE, and because of the SCAP, that got broadcast to the world, and the good guys found out about the problem and were able to make patches. Okay, so how do we achieve compliance with these new standards to make our factories safer? First, our legacy code must be updated. It's no longer good enough to write code or run code from 10 years ago. We need to make sure it's updated. We make sure that we're incorporating new and secure libraries into all of our code. Your development teams now need to be constantly aware and constantly checking for changes and updates to all the libraries they're using. It's very easy for a development team to become complacent. If you've got version 2 of a particular logging library, it's doing what you want. You don't need the new features. You're going to stick with version 2. no longer acceptable. If version 2 has a vulnerability, if it gets listed, you're going to be required to update that to the new version. So it's now incumbent on the development teams to monitor their own code, libraries are using, sub-libraries they're using, and make sure that those are being brought forward into new secure versions. We need to make sure that we've got a process to be updating our equipment in the field. As these libraries, fall out of date, they become vulnerable, they need to get replaced. We need to become much more comfortable with pushing patches out to the factories, out to tools that are in production. Again, not something that generally the factories are happy with because you don't want to risk making any kind of impact on production. We need to find a better process and a better way that we can do this more seamlessly. And then what's probably coming, this is not part of the standards. Semi as an organization will not push certification, they will not create certification, but it probably, I'm not going way on a limb here to suggest that the factories are going to start requiring some kind of certification, some kind of third-party audit to make sure that you're fully complying with all of these things and continue to comply. It doesn't exist yet, but looking forward a little bit, this seems likely to me, personal opinion. Next steps for all of us, next steps for the industry, more semi-standards are coming. So NIST, they've got those 5 different levels. We're starting to address some of the identify, some of the protect. We're going to look for these task forces to create even more standards to help us out. Step 1, looking at access listing. This would be trying to come up with a list of approved software to install, either on a given tool or at the factory level, to make sure that you're not installing factory that doesn't belong there, and finding a way to prevent that. Make sure that, again, help the humans from making a mistake. Don't let the human install a piece of software that doesn't belong on a particular tool. So they're working on standards towards that. And the other thing is that we're trying to become more sophisticated about equipment operator access, management, and monitoring. A lot of our tools right now, and you've probably seen this, you've got one username, one password. That's the administrator account. Everyone logs in as the administrator account and they use it. It's very convenient to have that set up. It's very simple, but you can see a lot of challenges with that. We want to make sure that the various operators, various humans, don't have access to features and functionality that they shouldn't have access to, or certain features and functionality. Even if I have access to do administrative level operations, I shouldn't log in using that account all that time. Most of the time, I should be using a low privilege account that can only do basic operations. And then every once in a while, when it's required, I could log in with a special account and do something. So to move towards that kind of world, we're trying to become more sophisticated, set some standards about creating these user accounts, managing these accounts, monitoring who has access, who's using different accounts, when they're used, what's being done, developing some semi-standards around that the industry can apply. NIST is looking to improve their cybersecurity framework. They're working towards version 2.0 right now and seeking input on that. And then we're having conversations like this. So talking to you here at APCM, either in person or virtually, and also at the Semicons, we're starting to see more and more communication on this. So Semicon Taiwan last year ran a major cybersecurity summit, and there's one that peer group will be participating with at Semicon West in July of 2023, where we're going to be meeting with some very senior people from factories, OEMs, software suppliers, bringing the community together and talking about these challenges and how we're going to address it together as a group. So thank you very much for listening to me here today. I know that security is not the kind of problem that people want to deal with, but we must deal with it, and the encouraging thing is that we are dealing with it, and solutions do exist. We just need to put the resources behind them to correctly move in that direction. Thank you very much.